So in this question here, we want to be taking the integral of 1 over 4 minus square root of h with regards to h. And then the question moves on to calculating information about the growth of a tree, and the height of the tree is in metres and the time is in years. That's the variable t and the variable h. Now we're given that the rate of change in the height is given this here, so dh dt, so it's height with regards to time and the change of, t to the power of a quarter times 4 minus root h over 20. So that's what it's been calculated as. What we want to do is find the ranges in the height possible with this formula here. And then part C is when a tree was first planted, it was a metre tall. How long will it be? How long will it take to be 12 metres tall? So that's part C. So first of all, let's go straight into this integral. So we've got the integral of 1 over 4 minus square root of h dh. Now, with this in the denominator, in this kind of integral, we just substitute all of that for u. So u equals 4 minus square root of h. And then with any integral, what we want to do is find the derivative of that when we're doing a u substitution. So that's what we must always do with a u sub. So let's take the derivative of this. So du equals, well, the derivative of a constant is always 0. Now we want the derivative of minus h. Well, minus h is the same as saying minus h to the power of a half. That's what that's equivalent to. So what we do is, when we've taken derivative, we multiply by this power out the front and then reduce that by 1. So then that gives us minus 1 over 2, and then reduce that by 1, we get h to the minus a half, which is just the square root of h in the denominator. So that's the square root of h in the denominator, and that's our dh. Okay, right, we need to get dh on its own to substitute into there. So then we'll get dh equals, multiply both sides by this 2 root h, and we could use the minus sign as well to get dh on its own. So if we do that, multiply this side by that, we'll get minus 2 root h, and then that's du. So that way then we've got the minus sign away from the dh, and we can just substitute all of that into there. But I see here, square root of h, we can't substitute that into here when we're doing a u substitution. So we need to find out what square root of h is in terms of u. So let's use our original one, u equals 4 minus root h. So to get root h on its own, let's bring that over here and then take the u over to this side. So then we'll get square root of h equals 4 minus u. So then dh, using this substitution, dh equals minus 2 times 4 minus u. And then that's du. Let's make a space to put our du. Okay, so now we've got all our building blocks to go into our u substitution. So now I've got the integral of 1 over 4 minus root h is u, and dh is this. So that's 2 times 4 minus u du, and there's a minus sign there. Okay, now this here is a constant multiple, so that can come out to the front. So now we've got the integral minus 2 times 4 minus u over u du. Okay, now what we're going to do here? Well, best thing to do is maybe split this integral into 2 parts. So now we've got minus 2, 4 over u, and then that's du. And then we could subtract another integral, but then as we're going to do minus 2, we can now add 2. So add 2 times 1, and then that's du. So you see what happened there. If we're going to do minus u over u, that becomes minus 1. Minus 1 times minus 2 gives us 2, so 2 is our integral there. Okay, well now we're almost ready to go straight into our integration. I'm just going to bring this 4 out to the front. So we've got minus 8, 1 over u du. So we know how to integrate that. And then 2 times the integral of 1 du. 2 nice easy integrals for us to do with our u substitution. So this is just the natural log. So I've got minus 8 times the natural log, absolute value. Now let's go back into our h variable. So u is 4 minus root h. So 4 minus root h. That takes care of that one. No need for a plus c just yet. And then we've got plus 2 times the integral of 1. So that's plus 2 times, the integral of 1 is just u, which is 4 minus root h. Okay, and now we could do the plus c. Okay, well, let's just distribute this 2 inside here and let's see what happens. So I'm going to write minus 8 natural log 4 minus root h plus 2 times 4, so that's plus 8, and then plus 2 times minus root h, that gives me minus 2 root h. So minus 2 root h plus c. Now this plus 8 can be absorbed by this constant multiple here. So now I'm going to bring minus 8 ln of 4 minus root h. Plus 8 I'm going to absorb in the c, and I've got a minus 2 root h here. Now 8 plus c, I'm going to give that a new variable because that's a new constant. So I'm going to just call that plus k. So k, where k equals 8 plus c. Okay, so that's the result of our integration. Right, now with that in mind, I'm going to write that up there as our result, and then I'm going to move on to part B. Okay, now let's concentrate on this differential equation here. Now we want the ranges in the height, so let's just have a look in here and see what makes sense. So for looking at the change in height with respect to time. Now at the beginning, the tree is going to have no height. That's when it's a seed at time 0. So part B, at the beginning, the height equals 0. Now it can never be less than 0, otherwise that just doesn't make sense. So the height is always greater than or equal to 0. That's what we want for a start. Now also in here, we don't want this to end up being a negative value, because if it's negative value, that means the tree is going to start shrinking. Now that's not going to work in growth. It's just not going to make sense. So what we want is when this here is at its maximum value. So for that, we want to set this bit in the brackets to 0. And that way then we can eliminate what the maximum value is at 0. So then we have 4 minus square root of the height equals 0. Bring the square root of the height over to this side. So 4 equals square root of the height, and it's positive. Square both sides. So then we get 16 equals h. So that's the maximum value before that becomes 0. So you'll see here 4 minus the square root of 16, that is when we're at 0. So what we want is the height of the tree to be between 0 and 16. So we've got the height of the tree is from between 0 to 16, and that's our height. And our inequality, we can put on there greater than or equal to 0 and less than or equal to 16. So put our equality signs in that direction. So that's the range in height of our tree. Okay, right, let's take those calculations off and concentrate on part C. Okay, so now part C. When a tree's first planted, it was 1 metre tall. How long will it take to be 12 metres tall? So for that, what we want to do is to break this differential equation down into a separable differential equation, and then plug in the height to be 12 and see what solution we get. So C equals dh over dt, which is t to the 0.25, 4 minus root h, all over 20. So as a separable differential equation, we can bring the t onto this side with these variables, and then the h variable can come over to this side. So now let's send the dt over there and the 4 minus h in brackets over to this side. So now we'll have 1 over 4 minus root h, then that equals t to the power of 0.25 and then that's divided by 20, and that will bring our dt over here. So we'll have a dt here and we'll have dh here. Okay, so now what we can do is we can take the integral on both sides, and then we can get the h and the t variables as we want them. So let's integrate both sides. Now the integral of this we've already done in part 1, so that's why we needed that. Let's just plug that straight in there. That's solved. There we go. So we've got minus 8 ln of 4 minus root h minus 2 root h. Now there's a constant of integration there, which I'm going to put at the end. So now I've got this one here, which is 1 over 20. So this one here is 1 over 20. Let's just put that there. 1 over 20. And then t to the power. Well, as I'm integrating, I'm going to write that as t to the quarter. It's easier for me to work with. I just like the look of the fraction. And that's dt. So this integral here is now 1 over 20 t to the quarter. So raise the power by 1, divide by the new power when integrating. So that's t to the 5 over 4, and then divide by 5 over 4. That's what we need to do, and then we add our constant of integration, which I'm now going to put as plus c1. So that's our new integral of constant of integration. So that equals that. Okay, now what have we got here? Well, we need to simplify this off a little bit. So we times this one here by 4 and divide by 5. That's going to give me 1 over 25, because that's going to give me 4 over 100, which is 1 over 25. So I've now got 1 over 25 t to the 5 over 4 plus c1, and then here just bring this down as it was, minus 8 natural log 4 minus root h minus 2 root h. Okay, now we need to try and evaluate what our constant of integration is. Now we know when the tree was first planted it was 1 meter tall, so when t equals 0 h equals 1. So if I just put this little bit here, t equals 0, then h equals 1. So if I plug that into there, we should be able to solve for c1. So t is 0, h is 1. So if h is 1, so I've got minus 8 ln 4 minus square root of 1, which is going to give me 4 minus 1 is 3. So I've got minus 8 ln, well, if I've got 3, I don't need the absolute value, so I don't have to worry about that. So ln 3 minus 2 times square root of 1, so that's just going to be minus 2. Now on this side, t is 0. Well, if t is 0, then all of this becomes 0. So I've got 0 plus my constant of integration. So therefore, my constant of integration is actually this. So what I can do now for my c1, I can just plug in this value here. So if I write here c1 equals minus 8 ln of 3 and then minus 2. That's my constant of integration. So now what I can do now is let's just try and solve for t when h is 12. So plugging in that. So now what I need is minus 8 natural log of 4 minus square root of h. So 12 meters tall. So I now need h equals 12. So now I've got my constant of integration sorted. So minus natural log of 4 minus square root of 12. Now that's also going to be a positive number because square root of 12 is less than 4. So that's fine to leave as normal rounded brackets. Then minus 2, h again is 12, so it's minus 2 root 12. And then that equals 1 over 25 t to the 5 over 4, and then my c1 is this, so let's just plug that in there. So minus 8 ln 3 minus 2. Okay, right, I need to get this t on its own. So this bit here, that can come over to this side. And to get t to the 5 over 4, I can multiply by 25 as well. So now I've got 25 times all of this input, which is minus 8 natural log 4 minus root 12 minus 2 root 12. Bring this as well over, which is still inside the brackets. So now these are going to change to a plus. So I've got plus 8 natural log of 3, which is the same as natural log of 3 to the power of 8. So that's going to be quite a big number. And then plus 2. So that's all in brackets. And that equals t to the 5 over 4. Okay, right. So now what I want to do, maybe distribute the 25 and then take everything to the power of 4/5 to get to this 1. Okay, so let's do that over this bit here. So let's get it all in there. So now I'm going to raise everything to the power of 4/5. So nice big bracket here. So I've got 25 times minus 8 natural log of 4 minus root 12 minus 2 root 12 plus 8 natural log of 3 plus 2. So that's all of that. Nice big bracket round that. Raise that to the power of 4/5 to cancel out this one. So that's the power of 4/5. Keep that bit, it's not part of that bit there, that's all separate. And that equals t. Okay, right. So plug all that into a calculator, you'll get that t is 75.15 and a bit. So t equals 75.15 da 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 da. So therefore, how long will it take to become 12 meters tall? You're looking at about 75 years, 0.15. So we're looking at about 75 years and nearly 2 months is what we're looking for. So approximately 75 years, and yeah, it looks like, because 1/12 of a year is 1 month, so 2 months is 2/12, which is a sixth. Well, a sixth is 0.1666, so approximately 75 years and 2 months, give or take a couple of weeks. Remember again, this is just an approximation. Okay, so that's our result.